All right, so we're starting 11.6, which is quadratic functions and their graphs. We're going to graph a parabola. So I guess this is new. Before we graph lines, but this is a parabola. Oh, okay. So let's share the desktop and let's start. Okay. Math 125. All right. So 11.6 is quadratic functions and their graphs. So anyway, the graph of a quadratic function is, so let's write down the graph. There are two ways of writing the quadratic function. F of x is equal to ax squared plus bx plus c, and f of x is equal to a times x minus h squared plus k. So is a parabola. Okay. So if we think about a parabola, what is important in a parabola? So if I have this parabola, what is important here? You have what is called the vertex, and you also have the this axis is called the what is it called? Axis. Let me write down correctly. So this is the axis of symmetry. All right. And of course, we could talk about the x-intercept. So if this is my x-axis and my y-axis, so this is my x-intercept, and y-intercept, and also intercept. All right, so those are what is important. Vertex, axis of symmetry, intercept. So that's what we're going to use when we graph. Yeah. And is this the only way that the quadratic function looks like? The other way is when it opens down. So your parabola can open down and it can look like this. Yeah. So the vertex is on top. Now, does this parabola, the one that opened down, has maximum value or minimum value? Does this parabola have a maximum value or a minimum value? Maximum value. So maximum value. Yes. And what about the parabola that opens up? Yes, minimum value. Where is the minimum value and maximum value? They are on the vertex. Right? Okay. So what we're going to do is graph f of x is equal to ax squared. So this is the first one. So probably I will put a here. Graphing f of x is equal to ax squared, right? So what we want to do is graph probably y is equal to x squared, y equals to 2x squared, and y is equal to half x squared. So that's what we're going to do. Yeah. And later on, we will build what does this minus h mean and what does this plus k mean, but that comes later. But right now, we will start with graphing y equals to x squared. How do you think we will graph y equals to x squared? Well, we will have a table. for each one of them, and we will graph them on one sheet. Okay. So x and y is equal to x squared. So what x should I choose? -2, -1, 0, 1, 2. Right? Okay, so -2 squared. What is -2 squared? So -2 squared, which is 4. -1 squared, 1, 0 squared, 0, 1, 4. Is it? Okay. What about if y is equal to 2x squared? So this is not x squared, but 2x squared. What will this be? 2 times -2 squared, which is 8. 2 times -1 squared, which is 2, 0, 2, 3. Are you guys follow what I'm doing? Yeah, okay. And then this is like half times -2 squared, half times -1 squared, half times 0 is 0. So half times 4 is 2, half times 1 is half. So this is half, this is 2. Okay. Good. Can we graph them on the same set of axes? Alright, so let's graph y equals x squared first. Yeah? So I'm going to graph y equals to x squared first. What am I doing? Erase, erase, erase. Alright, so like this. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Alright. So I'm going to graph y equals x squared. -2, 4 is right here. And then -1, 1 is right here. 0, 0 is right here. 1, 1 is right here. 2, 4 is right here. All right. All right, good. So this is my parabola y equals x squared. Yeah. So it is nice curve. It's like a U, not quite like a U because it's a U, but it is wider as x and y goes to the other direction, goes in the other direction. How about y equals 2x squared? So -2, 8. -2, 8 is right here. And then -1, 2 is right here. And then 0, 0 is right here. 1, 2 is right here. And then 2, 8 is right here. All right. Where is it here? So it is a little slimmer, like narrower. And it still touches 0, 0 though. I didn't draw this part correctly. Yes, it still touches 0, 0 and 1, comma 1. No, I didn't draw this part correctly. Oof, 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 oof. 1, comma 1. Okay. And then what about the y equals to half x squared? Oh no, it's 1, comma 2. What am I doing? Oh gosh. Oh gosh. I'm sorry. I wasn't paying attention. So this one is 1, comma 1. And then the other one is 1, comma 2, right? And negative 1, comma 2. So it's here. I was correct. It's narrower. Yes. It still touches 0, 0, but it is narrower, right? How about half x squared? X and y is equal to half x squared. How does the graph look? Is it wider? So negative 2, comma 2. Where is it? Negative 2, comma 2 is right here. And then negative 1, comma half is right here, 0, 0, half. And then 2, comma 2 is right here, so it's wider. It still touches 0, 0. All right. Yes. So what is the vertex? 0, 0. So y is equal to ax squared. The vertex is 0, 0. If I ask you what's the domain, what is the domain? Domain? What is the definition of domain? The x value. So what x's are possible? All real numbers? Yes. Yes. What about the range? From 0 to infinity. So does it include the 0? Yes. So 0 to infinity. Right. Let me not write the range because if a is negative, then it's something else, right? What about the parabola that opens down? What happens? Well, why do all my parabolas that I drew here open up? Because the coefficient of x squared here, this is positive. What about if I draw something when I have y equals to negative x squared? How will this look? How will y equals negative x squared look? The graph will open down. So it's going to look like this, right? So negative 2, comma negative 4, 2, comma negative 4. So it's going to look like this. So it will have the same shape as y equals x squared, but what happens? The parabola opens down. Yeah. So let's write a conclusion. If a is greater than 0, what happens? Parabola opens where? Up or down? Opens up. But what happens if a is less than 0? Parabola opens down. All right. Are we okay so far? Okay. Good. So if a is greater than 0, parabola opens up. And if a is less than 0, the parabola opens down. Yeah. Now, actually, why do we learn parabola? Is it necessary? So let's just say I throw something here. So I don't know. Is it a bow? You could throw a bow. So let's just say I throw or shoot a bow up. So I'm not like Jennifer Kaplan straight, but I shoot it up. Okay. So this is my arrow. It's going to go up, and then what happens? It's going to reach the highest point. Then what happens? It's going to come down, and this is going to follow a parabolic pattern. So the trajectory or the path is going to be a parabola. Do you know why? Because of the gravity. Yeah, the gravity has something with a square. So it's going to, your trajectory is the path, will be parabolic, and it's going to go down. So then here. So instead of shooting a bullseye here, what happens to my arrow? It's going to go to the sky and then come back down. Yes? Hopefully I won't hit anyone. Yes? Okay. Do you guys do archery? Oh, you do? Okay. Yeah, where is the range here? Oh, okay. But no, there is one. There's a few, right? In Pasadena, in Azusa. That's what I heard. I've just never done it. Yeah, Azusa has it? Yeah. Okay. So, all right. Anyway, which one has parabola that opens down? When does it open down? When A is negative. Yes? So when A is less than 0. Okay. Now, what we could do is, well, let's do a demo in Desmos. So I'm going to show you a little bit. Let's see here. This is, did I ever open Desmos.com? That's a good calculator. So the website is www.desmos.com. Maybe I will write it on the board. So just in case you need it. So it's www.desmos.com. This is a graphic calculator online that I use for my other classes, because I don't let students use graphing calculator. I don't require them to buy, so whenever I ask them to graph using graphing utility, then this is it. So let's graph y equals, so y is equal to x squared. X squared. Okay. So this is y equals x squared. And you got these, right? Now let's compare this y equals to negative x squared. So y equals to negative x squared. Alright, so let's see. What do you see? Do they have the same shape? Yeah, only one. Okay, so you actually reflect this about the axis. This is a reflection about the axis. Okay. And what else do you see? Is this parabola symmetric? Yes. Where is the axis of symmetry? So let's look at y equals x squared. So the axis of symmetry passes through the vertex. Yeah. Okay. So let me erase this one. What about y equals 2x squared? Do you think it's narrower? Okay. So 2x squared. See, it's narrower. Y equals 2x squared. Now, wider if you have y equals to 3x, half x squared, half x squared. There's my square. X squared. Do you see it? The green one is wider. Yeah. So far so good. Okay. Now, let's go back to our journal and let's explore a little more. So it's wider if it is half, and it's narrower if it is greater than 1. So it's vertically stretched. So we call this graph. The y equals 2x squared. This is vertically stretched. And the other graph, y equals to half x squared. Half x squared. We call this vertically compressed. Yeah. So that's why it's wider, because we compress it vertically. All right. Now, let's continue. What about if I have y is equal to ax squared? All right. So let's talk about B. What about if I have graphing y is equal to a times x minus h squared? Okay. So before, what did we graph before? Y equals to ax squared, right? This is before. And then the a is a constant. Now, what we're going to do here, we're going to explore, for example, I am going to graph y is equal to x squared, and y is equal to x minus 2 squared, and y is equal to x plus 3 squared. Yeah. All right. Now, can you tell me what is h here? If I write it as y equal to x minus h squared, what is h here? Is the number which is 2? 2 or negative 2? This is important. H is 2 or H is negative 2? So H is 2. Right? So this is your H. Now, if y equals x plus 3, what is your H here? Okay. Now, you will notice as soon as I open the Desmos calculator, this is the same graph, but this is shifted right 2 units. So it will be the same graph, like y equals x squared. It's just that it's shifted right 2 units. What about when h is negative 3? Shifted left 3 units. All right. So why is it shifted left? Because this is negative 3. H is negative. Why is it shifted right? Because H is positive 2. So I'm going to open my Desmos again. Yeah. It's not important to do it using table, but I'm going to open my Desmos again. As long as you know that H is equal to 2 here, which means it is shifted right, then you will see what we need. So let me open Desmos again. Where is my Desmos? Here? Oh, no. It's right here. Okay. So I'm going to erase this, and I'm going to do something else. Y equals to x minus 2. Okay, and what do you expect? We shift where? To the right. X minus 2 squared. So where will it be? If I shift it to the right, what does it mean? Then I will have, my vertex is not 0, 0 anymore, but where? 2, 0. Okay, good. All right, you see it? Exact same graph, it's just shifted right 2 units. The vertex, everything else. Before it's this point, now it's this point. Before it's this point, now it's this point. Before it's this point, shifted 2 units to the right, so 2 units is here. And before it's this point, it's shifted. Everything is shifted. Does that make sense? Okay, so what is the vertex? 2, 0. Why does it open up? Because coefficient of x squared is positive. Yeah. Okay, so let's grab another one, which is y is equal to x plus 3 squared. So what were you expecting? What were you expecting? Shift left. Okay, so this is my original. Let me write this. This is my original. And if it shifted left 3 units, where will my vertex be? Negative 3, 0. So now it's right here. When I shift it, my vertex will be here. Yeah. So let's see. Oh. x plus 3 squared. So did you see it? Yeah. So the vertex is negative 3 comma 0. Alright. Yes? So can we write a conclusion here on our so what happens here? So if H is positive, what do? We shift. And if H is negative, what do? We shift. Yay, nay? Should we graph it here or no? You guys will know. Yeah, exact same shape, same everything. So this is a horizontal shift. The H is a horizontal shift, left or right. Yeah. Okay. Now, are we okay so far? Do you want to graph it here or no? So let me just graph it really quick, okay? So we know what the effect would be, so I don't think we need to graph it in detail. So for example, this is y equals x squared, for example. So this is 0, 0. Then what? So let's just say this is 2 comma 0. This is y is equal to, it has to be the same shape, okay? Because the shape doesn't change, only shift it, like if you move it. So this is y equals to x minus 2 squared, which means you shift right 2 units. And what about the other one? Negative 3. So this is what? Y is equal to x plus 3 squared. Yay or nay? Okay. Now, the next one would be graphing y is equal to 8 times x minus 8 squared plus k. So we know what these do. So now we're interested in finding out what happens if I have plus k. What do you think? It moves up. Okay. Oh, should I combine them now or should I separate them? Hold on, let me see. Y ax squared plus k. Yeah, I think we could just do it together. Yeah. So this plus k, what does this plus k do? Move up or down. Yeah. So H here is horizontal shift. Horizontal means left and right. Right? And then what about K? K is vertical shift, meaning up and down. Vertical is up and down. So for example, if I want to graph y, this is my basic graph, y equals x squared. But I want to graph y is equal to x minus 3 squared plus 2. All right. And I also want to graph, so this is 1. This is 1 is my basic graph. This is 2, this is 3. 2, 3. Okay. What about if I have y is equal to x minus 3 squared minus 4? So what do you guys think? Can you tell me the shift? On number 2? Do I shift right or left? Yes, so this is shift right. Why is it right? Yes, H is positive 3, right? How about this plus 2? Shift up. So K is 2. So K, there is no change, right? Shift up 2 units. Good. So tell me what the vertex is. What is it? 3 comma 2. Yes. Because you shifted right 3 units, you shifted up 2 units. So 3, 2. Good. So you could actually read it. Your vertex is H, K. Isn't that right? Now, what about the second one? What type of shift do you think happens here? Shift right 3 units? Okay. And then shift down 4 units. So tell me what the vertex is. What is the x coordinate? 3, -4. So you see, you could read the vertex from here. 3, -4. Yeah. Okay. Can we add the vertices for the ones we did before? So what is the vertex here? And what is the vertex here? I was going to add these. Can you tell me if I shift right 3 units, what is the vertex? 2, 0. And what about here? You shift left 3 units, so it is -3, 0. Are we okay so far? So I'm going to graph these two, okay, using decimals. Yeah, okay. All right, ready? Okay, so let's see. Oh, I was going to use decimals, right? So let's erase this. Okay, what did we say? Is it x -3 or x +3? X -3? X -3 squared. And then what did you say, +2? So let's see, it's going to go up 2 units. I think I should bring this down so you can see. So this is x -3 squared, shift right 3 units, but I'm going to shift up plus, yeah. Now, the other one, y is equal to x -3 squared. This is y equals x -3 squared. And then what about the other one? Is it -4? Is it -4? Yes. So what did you predict? Where is the vertex? Down 4 units. So you see this is 0. Same shape. It's just you move it down, you move it up. Are we okay so far? Okay. So we're going to write a summary, and then we will graph from scratch. Yeah. So we're not going to use decimals anymore. We will graph from scratch. We will find the intercept. We will find the axis of symmetry, etc. Now, if I were to ask you, where is the axis of symmetry of this graph of y is equal to x -3 squared plus 2? Where is the axis of symmetry? It's going to pass through the vertex. Yeah. What is the equation of this line that passes through 3, 2? The vertical line that passes through this one. X is equal to 3. Yes. So if I'm graphing here, x is equal to 3, you see this is my axis of symmetry. And as you can see, they're symmetric. Okay? So this is what? This is 5, 6. This is 2 units from the axis of symmetry. So you also have, what is this? 1, 6, which is 2 units from the axis. So 2 units to the right, 2 units to the left. Are we okay so far? So now we're going to write a summary, and then in the next section we will graph from scratch using it. So no longer using calculator. Okay? Good. Okay. Let's write down the summary of this graph, and then we will graph by hand. Yeah, all right. Okay, so suppose I have the summary So f of x is equal to a times x minus h squared plus k. Okay. Tell me what this is parabola. So a parabola opens up. When does a parabola opens up? When a is positive. The coefficient of x squared is positive. And it opens down when a is negative. Note a is coefficient of x squared. Coefficient of x squared. Do we know the vertex? What is the vertex? Come on, you know this. Vertex coordinate. It's h comma k. Yeah, you are right. So it is h comma k. Good. Because of the shift, remember? That's why it's h comma k. And we also have the axis of symmetry. What is the equation of the axis of symmetry? X is equal to h, right? Because it passes through the vertex. All right. Yay. So are we graphing now? So we're going to graph by hand. Yeah. So when we graph, this is what we're going to do. So, for example, graph. So we follow this step. Follow the steps. So what are the steps to graph? A, determine if the parabola opens up or down. Okay. So determine if the parabola opens up or down. And then B, write the coordinates of the vertex C, find the axis of symmetry. So write the equation of the axis of symmetry all right. And the x and y intercept, find the y-intercept. And then x-intercept is optional, but we will try to do it a minute also. So I'm going to write down. Sometimes it's difficult to factor. We won't use it on our graph. So optional. So I'm going to write a note here. If difficult to factor, if the expression is difficult to factor, we skip finding. We won't use the x-intercept. Maybe I should say that. We will not graph the x-intercept. Okay, so which one is optional? The x-intercept. Yeah. The y-intercept is easy to find, but sometimes the x is a little bit harder. So sometimes we don't graph it. Yeah. So A, use additional points and symmetry to graph. And I usually like you to label 5 points. Label how many? 5. And I asked you, what is the maximum or minimum? Oh, let me put the F here. Sorry, no space. F, determine the maximum or minimum value, function value, which is the y coordinate of the vertex. All right. Are we okay so far? Okay. Good. So let's graph one now. Yeah. Let's see. What about these? You ready? Right, maybe let me do this. Now, so for example, graph use the A, B, C, D, E. Number 1, f of x is equal to negative of x plus 1 squared plus 4. All right. And follow the steps A through F. Use A through F. All right. So A, does the parabola open up or down? Down? So I'm going to graph this. So my parabola later on needs to open down. So A is equal to -1. The parabola opens down. What is my A here? -1. Negative. Less than 0. Yeah, this is less than 0. B, what is the coordinate of the vertex? What is H here? -1. Not 1, but -1, comma 4. Okay. So I could start graphing actually. So I am going to graph here, right? Once I find the vertex, I could actually start graphing. And then I will know which points that I need. So -1, comma 4 is 1, 2, 3, 4, right here. All right. That's my vertex. Now, the next one, so and I know it will go down, so you would expect it, so you should imagine, oh, it's going to look like this. Of course, this is not accurate, but you will imagine, oh, this is my vertex, so it's going to look like, oh, actually, this is my vertex. So it's going to look like this. Yeah. So if your graph later on does this, then you know we did something wrong, right? All right, now let's talk about the axis of symmetry. Well, first of all, where is it on my graph? Where, if I want to graph it, what would I do? It's going to be passing through my vertex. So this is my axis of symmetry, and what is the equation? X equals -1. Yes, you're right. That is my axis of symmetry. And I will box this. Well, actually, I used this already, but it's on the graph, so I'm just boxing them. Good. Now, do we have an asymptote? Asymptote, what I was talking about, y-intercept? What is y-intercept here? How do I find y-intercept? Set x equals to 0. That's right. So f of 0 is negative of 0 plus 1 squared plus 4. So what is f of 0? What is it? 3? Yes, f of 0. So negative 1 plus 4 is 3. Can you write the y-intercept then? In ordered pair, this is a point, so we will write it as ordered pair. What is it? 0, 3. And I'm going to draw it now. 0, 3 is right here. So that is 0, 3. Right? Do we want to try to find the x-intercept? So yeah, we could do it. So x-intercept. I think we could practice, right? How do I find x-intercept? That y equals to 0. So negative x plus 1 squared is equal to plus 4 is equal to 0. Okay, good. Now what? How do I solve this? Subtract 4 both sides. So negative x plus 1 squared is equal to negative 4. Divide by negative 2. Negative 1. So x plus 1 squared is 2. Okay. Then what? Complete the squares? Yes. How? Oh, this is 4. How did I get 2? 4. Yes. When I take the square root, what happens? Plus or minus? Yes. So we have x plus 1 is equal to plus or minus 2. So x is equal to negative 1 plus or minus 2. So negative 1 plus 2, 1. Oh. 1. Oh. Yes. What's the other one? Negative 1 minus 2, which is negative 3. So do we know what the x-intercepts are? 1, 0 and negative 3, 0. All right. Okay, so now where is 1, 0? Right here. This is 0, 3. And the other one was negative 3, 0, so it's right here. All right, now, do you think you know the shape of the parabola? Sort of. How many points do I have now? 4. I need how many? 5. All right. How do I get the other one? Can we use symmetry to get the other one? How do I use symmetry? Oh, then I look here. Oh, this is my mirror, my line of symmetry, my axis of symmetry. How many units does it go here? 1 to the right. So you will have a point where? 1 to the left. And let's label this point. This is negative 2, 3. This one. And how do I get that? By using symmetry. Yeah. Now let's just draw the parabola. Woohoo! Oh, that looks pretty good. So this one is by symmetry. Does everybody know what I mean when I say by symmetry? What do I mean? Yes. So you look at the mirror, you're right, Alex, and then what do? If it is one to the right, then you have one to the left. Yes, that's right. Now, this is by symmetry. Yeah. Okay. What if you don't have the x-intercept? Then you just choose some points. Yeah. Now, does the function have maximum value or minimum value? Maximum. What is the maximum function value? This is the y-coordinate of the vertex. So maximum function value is 4. Not -1, 4, but 4. For why this is which is the y-coordinate of the vertex. Yes? That is the y-coordinate of the vertex. So the function has a maximum value, and the maximum function value is 4. Remember, it is the y-coordinate of the vertex. Are you comfortable? Should we do another one? Do another one? Okay. Let's do another one. So sometimes we don't find these. So this is the optional part. And when do we find the x-intercept? When it is easy to do. Yeah. What if I don't use this point? Well, I need to find one more point, and then I have to do the other one by symmetry. All right? Doable? Okay. Do another one? All right. Okay. So number 2. What about if I want you to graph f of x is equal to 2 times x minus 2 squared minus 4. And I will follow the A through F. All right. Now, the first question is, does the parabola open up or down? Yes. Why do you say that the parabola opens up? A is 2, which is greater than 0. Good. Where is my A? This is my A. That's your A. Now, what about the vertex? What is my vertex? Come on, you know this. 2, -4. That's right. 2, -4. That's my vertex. Because I shift right or left here? Do we shift right or do we shift left? Yeah, we shift right too. That's why your vertex is moved 2 units to the right. 2, down 4. Right? Okay. Now we're going to graph 2, -4. Once we have the vertex, we could actually start graphing, and then start graphing the axis of symmetry. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 2, -4 is right here. This is 2, -4. So once I have my vertex, I could start graphing. So, good. Now the next one is axis of symmetry. How do I graph my axis of symmetry here? How am I graphing my axis? It's going to pass through the vertex. Yes. It's a vertical line that passes through. Do I know the equation of the axis? This is a vertical line, so it is x is equal to 2. Yes. All right. Good. What's next? X-intercept, Y-intercept? Y-intercept? All right. How do I find y-intercept? Set x equal to 0. So f of 0 is equal to 2 times 0 minus 2 squared minus 4. So this is 2 times 4, 8 minus 4, which is 4. So 0, 4. Right? So 0, 4. Where is 0, 4? Oh, 1, 2, 3, 4 here. Oh, I'm using red. Am I right or not? So 2 times 4 is 8, right? 8 minus 4 is 4. Okay. Good. Now, do we want to find x-intercept? Yes, no? This is optional. We could try. So but then we probably don't need to. So let's just skip it. So what about if I want to graph use additional points? So this is finding additional points. Graph use additional points. So what points do you think I will use? Any idea? We're almost done. So x, what x do I choose? So y is equal to 2 times x minus 2 squared minus 4. So look at your graph. Which points do you have? Are you guys okay? Yep. Now look at here. Okay. Oh. Well, you can't look at anything now. Now look at here. Okay. I am going to want to use my symmetry. Yeah. So I have a point which is here and here. So probably I could choose when x is equal to 1. What happens when x is equal to 1, right? And then I will choose the other point by symmetry. I will find the other points by symmetry because I have the one on the left already. Here, do I have it on the left? So this is 0, x equals 0, and x equals to 2. So maybe we should try x equals 1. So to minimize our work. So when x is equal to 1, what is y? 2 times 1 minus 2 squared minus 4. So this is 2 times 1 minus 4. What is 2 times 1 minus 4? Negative 2? Yes? So 2 minus 4 is negative 2. So it is 1 comma negative 2. Where is 1 comma negative 2? Is right here. 1 comma negative 2. So now we could graph half of it. It's a little bit harder for me to graph the one on the left, but let's try to make it look better. No, it's not going to be pretty. So it is going to look like this. What is this? Okay. Okay, anyway, this one should be smooth. I don't know why it looks like this. Okay, hold on. All right, almost done. Yes. Are we done with my problem? No. What am I going to do? We do our symmetry. So I'm going to find a point here. How do I find a symmetry? Yeah, how many spaces here? 1. So then you have 1 here. What is this space called? 3, comma, -2. Yeah. So I didn't calculate this, but I found this using symmetry. Now what about the other one? Then I say, oh, this is 2 spaces to the left. What about 2 spaces to the right? Yes, 1 more here. So what is the coordinate? 4, comma 4. Yeah. So that's it. So those 2 points in blue, we didn't calculate, but we found it through symmetry. So these 2 are by symmetry. Okay, almost done. Do I have max or min? Min. So what is the minimum function value? What is it? -4, which is the y coordinate. I always write this so you remember. It is the y coordinate of it. Yeah. So these 2 are by symmetry. Why do I use by symmetry? Because it makes your life easier, isn't it? You don't have, otherwise you have to calculate more here, and sometimes when you calculate, it's wrong. So we just use symmetry. So these 2 are by symmetry. Are we okay? Okay. So tomorrow we're going to graph quadratic in this form, ax squared plus bx plus c. Tomorrow. Yeah, which is fun also. Yes. Sounds good? Okay. So this is something which we use a lot. So make sure you can do it. Yeah. Okay, guys, I'm done with 11:6. So I guess the homework's due on Wednesday. Yeah. Yes, I know. Okay, thank you. I will see you tomorrow. Yeah. Right, let me close this. Okay, so today we finished 11.6 quadratic functions and their graphs. Tomorrow we will do more graphing, but quadratic function in a different form.